By far, the most popular unsupervised learning algorithm is k-means clustering. In k-means clustering, the algorithm learns clusters, and the number of clusters that it learns is specified by the user, who specifies the value of the k parameter. So for example, if you wanted to find 5 clusters, then you would run k-means clustering setting k equal to 5, and you might get an output similar to what you see below. If you reran k-means clustering, but instead set k equal to 3, then you would get 3 circled clusters, not 5. So that's the output of k-means clustering. How does k-means clustering work? Let's try to cluster these sets of data, the circle points. And the first step of k-means clustering, it's an iterative algorithm, is to randomly initialize a quote center of each cluster. And we denote these in this picture with these squares. So we have all these data, and we just randomly assigned these 3 starting cluster centers, which are these 3 squares, randomly chosen. So the next step is to then find what are the closest points to each cluster center. And that will be our initial sets of clusters. So we just randomly threw 3 squares onto the page, and these points were closest to this square, so this is the initial cluster 1. These points were closest to this square, so that's cluster 2, and these points were closest to this square, so that's cluster 3. That's the starting point. The next step is, now that we have these clusters, we aim to recalculate the center point of each cluster. So, for example, for this cluster to the left here, the points are all around here, so the square way up here is not the mean point. The mean point is probably somewhere down here in the middle, where we take the average of the x values and the average of the y values, or I guess in this case the average of the x1 values and the average of the x2 values. And by the way, you can have as many xn's as you want. You could have x 100, x a billion, whatever you want, same concept. So we take the average and we calculate the new mean point of our cluster. So by doing that, our squares move to the mean point of all the points in the cluster. So now we have these new squares, and then we redo the process again and again until the cluster stops changing. So for example, now that we have this square cluster, we can recalculate what are the closest points to each square, and notice that the clusters change a little bit. Then we do the same thing, recalculate the mean of that new cluster, find which cluster center each point is closest to, recalculate until it stops changing. And when it's done, we'll end up with a pretty good clustering, and in particular, a pretty good group of k clusters. Now, let's look at where we started. We randomly started with these clusters, which seemed a bit off, and just with 1 or 2 iterations of this algorithm, we already ended up with this clustering, which is much better. And so that's k-means clustering for you. The math behind it is pretty similar. We're satisfying this objective function, just breaking it down. So we're looking at the distance between a point x, an n-dimensional point x, and the mean of cluster I. So we sum over all clusters Ci, where I is the index of the cluster, and we also sum through all the numbers of clusters, so sum through all clusters, sum through all points in the cluster, and we want to find the cluster definitions, the points of the assignment of points to clusters, such that the summation of all points is minimized between each point and the mean of that point in cluster I. So that's essentially the math definition of the process I just outlined. And that is how k-means clustering works. It is by far the most popular unsupervised learning algorithm.